Problem 7.3. Using mathematical induction, prove that 1 plus 3 plus 5 plus etc. plus 2n minus 1 is equal to n squared. Basically, that means that if you take the first n odd numbers, they will add up to n squared. It's quite an unusual thing to prove, if you think about it, but I will show you that it makes a lot of sense. So, let's see. As in the example number 1, we have 3 steps. Step 1. Does it work for n equals 1? Well, yes it does, because 1 squared is 1. If you plug in 1, it will be 1 squared is 1, and on the left hand side it's also going to be 1, because there's only one odd number, so it works. So the base works, so for n equals 1. Step 2. Assume that it works for n. Assume that it works for n. Then for n plus 1 is going to be, so if the first n odd numbers is n plus 1, if you take the next odd number, that means you are adding the next odd number, and the next odd number after 2n minus 1, the next odd number after 2n minus 1 is 2n plus 1. Try to prove it by yourself. So I have the sum of the first n odd numbers, which is n squared. So n squared plus 2n plus 1. So I'm adding the next odd number. Actually, I'm just going to go a bit deeper into that. I'm going to write this. So 1 plus 3 plus 5 plus etc. plus 2n minus 1. I'm going to add the next odd number, which is 2n plus 1. But we have already proved that this thing is n squared. Therefore, if this is n squared, we can write n squared plus 2n plus 1. We can then notice that this expression can be factorized. So two numbers that add to 2 and multiply to 1 is 1 and 1. So it's going to be n plus 1 times n plus 1, which can be simplified n plus 1 squared. So what did we do here? Using the fact that this expression is n squared, we proved that the whole expression is n plus 1 squared. Therefore, if the formula works for n, it works for n plus 1. If the formula works for n, it works for n plus 1. So connecting the two steps, step 3, knowing that if the formula works for n equals 1, we can prove that it works for n plus 1, so for 2. If it works for 2, it works for n equals 3. Well, you got the point. So it works for all n which are positive integers. And that's it. So I think the hardest bit here is actually doing this and comparing this to the formula which you get if you substitute n plus 1. Because if you substitute n plus 1, you get this formula. If you substitute n plus 1 here, you get this. And that's it. So we proved it.